Hey guys, so today I'm going to be going over the activity Why Are the Oceans Deep Part 2. I'm going to cover how you can set up your diagram so that you can figure out how to solve the problems that are on the other side of this page. So to begin, I'm going to go over the values that you're going to be using. There's this table right over here that has all of the values with their units that you'll need except for the density of oceanic crust, which is written right over here. So I'll have you guys look at that and follow along while I draw this diagram. I'll draw it on here, but it's probably going to be best if you draw yourself a larger diagram on the other side of the page, just so you have a reference sheet that you can see at all times. So if you look at this diagram, you can see 120 kilometers as the plate thickness for the oceanic lithosphere, and then we have the same value over here for the continent. So what I'm going to do is, based on the activities that we had done before, I can draw a line in to differentiate different parts of the plate that would have different densities. So right over here, I have my oceanic crust, which is 7 kilometers in thickness, which is on your table that is to the right of this diagram. And I will label it with OC for oceanic crust. And then to the right of it, I have continental crust up above on this plate. So put a CC. And according to our chart, the thickness of the continental crust is 35 kilometers. So using this total value over here and the value you have over here for both of these crust values, you can figure out how thick this part of the plate is. So I got 113 kilometers and 85 kilometers. Now, what you'll need to know is how to set up the left and the right side of the equation. So what I like to do first is to put in my values on my reference guide and then go from there and follow the instructions. So starting with this column right over here, I have seawater, so I'll know how I have to use the density of seawater in my equation, which is equation 3, which is in the middle of this page that I'm on. So what I can do is put the value for that, or the symbol for that, which is a rho sub W. For oceanic crust, I'll put a rho with an OC for oceanic crust. And then for the rest of this, I will put a rho and an M for mantle rock. And then on the other side, what I'm going to put is a rho and crustal rock, which is a C. And then for the rest of that, it will be rho M for mantle again, mantle rock. And then draw a dotted line going down, and this is not water. This is also crustal rock. So, using equation 3 right over here, you'll set up an equation for both of these that gives you the pressure at the base of the unit column, which would be right over here for the ocean side, and right over here for the continent side, and then you'll make both of those equations equal to each other. So it'll look like this. Pressure is equal to the densities in that column times gravity times the height of each of those different densities in that column. And you'll have the same thing on this side. So the pressure is equal to the density, the different densities times gravity times the different heights. So you may have more than one values for the pressures and the heights, and you'll have to keep them together. So let's see. If I continue on, for the ocean side, I could have pressure is equal to, and I'll put gravity off to the left, just to keep it away from all the extra numbers. And then I'll start at the top of the column, which is seawater. So I have the density of seawater times its height, which is delta H, and I'll put it in parentheses, plus the oceanic crust, so the density of oceanic crust times its height, which is 7 kilometers, plus the density of mantle rock times its height, which was 113 kilometers, and then I'll have that equal the same values for the continent. So if we go forward, I'd have gravity again times the density of continental crust times its height, which is 35 kilometers, plus the density of mantle rock times its height, which is 85 kilometers, plus another set of mantle rock, so the density of mantle rock times delta H. And what you would do for the entire equation is solve for delta H. Alright, you guys, so what I'm going to do now is take this equation that's right over here. Remember, this side is for the oceanic side, and this side is for the continent column. And I'm going to show y'all how to solve for delta H. So, right over here, I'm going to quickly rewrite the equation. So I have gravity times the density of water times its height, which is delta H, plus the density of oceanic crust times its height, which is 7 kilometers, plus the density of the mantle times 113 kilometers is equal to, which I'll put down over here, gravity times the density of continental crust times 35 plus the density of mantle rock times 85 plus another set of the density of the mantle times delta H. So what I'm going to do next is take this equation and have it solve for delta H. So we already know that because we have gravity on both sides of the equation, we can cancel them out. So we're left with just the densities and their heights. So the first step in solving this problem is to isolate your variable and keep it on one side of the equation. So I'll start by putting the density of water times delta H from the oceanic side and subtract this value, which is the density of mantle rock times delta H, and have it equal to the rest. So cross these off so that I know that I've accounted for them in this new part of the problem. And I'll move these over by subtracting them to put them on this side. So first, I'll write down these two values since they're already on that side of the equation. So I have the density of continental crust times 35 plus the density of mantle rock times 85 minus the density of oceanic crust times 7 minus the density of mantle rock times 113. So I now have accounted for these values. And then the next thing I'm going to do is divide out delta H so I can further isolate it. So I can say delta H times the density of water minus the density of mantle rock. And the reason why we have a separate density for water is because it's not just regular water, it's seawater. It has a different density than regular water. And all of this is equal to everything up there. So the next thing you will do is divide out this set of parentheses so that you can have delta H be all on its own on the left side of the equation. So divide out density of water minus the density of mantle rock. It'll cancel on this side. I'll put it down here. Density of water minus density of mantle rock. And then you can plug in the values that you have on this page that are right over here. And don't forget, you have to add the density of oceanic crust. It was just left off of the page. But after that, you'll have the value for delta H, and you can solve the rest of the problems that are on the back of this page. Good luck!